Hello. So in this lecture, I'm going to give a brief idea of Boolean algebra. Okay. And whatever the Boolean logic operation generally will do, uh, I'll be discussing on those operations. So first of all, what is Boolean algebra? Okay. So first of all, you need to understand what is Boolean algebra. So Boolean algebra basically used to simplify the design of the logic circuit. You can note it down. It can be used to simplify the design of a logic circuit. So suppose we have given a large expression. Okay. Now, if we have to implement that thing by using some sort of logic gates, then it needs more number of gates. And whenever we are designing something, we try to use the number of gates as less as possible. Okay. So Boolean algebra, what it will do, it will help us to do the uh, minimization of expression. So whatever expression you have, uh, using Boolean algebra, you can do the minimization of that expression so that the number of variables or number of terms can be reduced in the expression. And as a result, the number of gates means the number of gates will be can be given in the minimum form. Okay, so the number of used gates will be in minimum form. Okay, so and let me tell you, it is different from ordinary algebra. Okay, the Boolean algebra is it is different from ordinary algebra. So it is different from ordinary algebra. What does it mean? Suppose in case of Boolean, if you have a variable a and if you do OR operation with a, then you know that is only a. Whereas in case of ordinary algebra, if a is there and if we add a, that is 2a. Okay. Likewise, if you have a variable, if you do the AND operation, so again the result is a. Whereas in case of ordinary algebra, if you do this type of multiplication operation, it will be a square. Okay, this is for ordinary and this side is for Boolean. Okay, so two things I told regarding Boolean algebra. One is it is used for the simplification of the expression. Okay, when you will be having some expression and it will be asked to design that expression by using some gates, then first of all, what is your main target? You need to somehow minimize that expression, and that is possible by using Boolean algebra. So that minimum number of gates can be used. Okay. And the next point is what I told, Boolean algebra is different from the ordinary algebra. Okay. Then some example also you can give some more examples. Suppose if I have given 1 and if you're doing the OR operation with the 1 plus 1, in case of Boolean it is still 1, whereas in case of ordinary algebra 1 plus 1 equal to 2. Okay. Now you can come for the next thing. What are the operation generally we do using Boolean algebra? So first of all, let me write down the heading Boolean logical operational logic operations. So what are the operations generally we do? All of you know these things very well. Suppose AND operation. We start from AND operation. So what is AND operation? AND operation means if you have given two inputs A and B, if it is applied through AND gate, and this is the symbol of AND gate, what output you are getting, if it is Y, then Y can be given as A and B. Okay. And what is the truth table of AND gate? I think all of you know. A and B are the inputs. These are the inputs of AND gate. Two inputs are there in the AND gate, and one output is there that I am denoting by it by Y. So using two input, how many combinations you can make? This is a very simple formula, 2 to the power 2. As you have two variables, you can make 2 to the power 4, 2 to the power 2 or 4 different combinations. So what are these combinations? 0, 0, 0, 1, 1, 0, 1, 1. These are the four combination. And what is the output in case of AND gate? 0, 0 means 0, 0, 1 means 0, 1, 0 means 0, 1, 1 means 1. So in case of AND operation, both the input or how many inputs are there, that input has to be, all the input has, have to be 1. Then only we will get the output of 1. If one of the input is 0, then output will be 0. This is the principle of AND gate. Okay, and this operation is known as AND operation. Okay. So this is the first operation I have shown for Boolean logic operation. Then the next one is OR operation. Okay. So what is OR operation? OR operation can be given in this expression, can be given by this expression, that is A or B. Okay. So all of you know this is the symbol of OR gate. You have input A, you have input B, and Y is the output. Okay. Fine. Now, what is the truth table of OR gate? You have two inputs, A and B. You have one output, that is Y. Using two variable, I already told four combinations are possible, 0, 0, 0, 1, 1, 0, 1. And in case of OR gate, the logic is if one of the input is 1, then only the output will be 1. Okay. So in the first case, both the inputs are 0. None of the input is 1, that's why output is 1. And for all the remaining case, at least one of the input is 1, so that's why the output will be 1. Here, at least one of the inputs should be 1 to get the output of 1. Okay, so this is the principle followed in our operation or OR gate. Now, third one is NOT operation. This is a very simple one, NOT operation, where you need to use NOT gate. And what is the symbol of NOT gate? All of you know. Okay, if you have given A and if your output is Y, in this case you have only one input, you have only one output. So NOT operation is a very simple operation. If you give 0, you will get 1. If you give 1, you will get 0. Okay, and this is given as Y equal to A bar. This is the expression given for NOT operation, Boolean expression. Okay, now we'll come for the next operation, that is known as NAND operation. So NAND operation is just whatever AND operation you have understood, you have to use the NOT concept there along with the AND operation, and this is known as NAND. So NAND gate is given as like this way: A and B are the inputs. What AND gate you have used, that you can use, and along with that one you need to give one bubble. So this will make the NAND gate, and this is the output. Okay, so what is the expression of NAND gate? You first write down the expression of AND gate, give the bar. Okay, this is the NOT operation you are doing. So whatever AND operation, AND result you got, you need to apply one NOT operator there. So it will become NAND. Okay, now what is the truth table of that one? You have two inputs A and B. Why is the output? So first of all, you write all the four combinations 0, 0, 0, 1, 1, 0, 1. These are the four combinations possible using two variables. Okay. Then what should be the output? What output you got for AND? You need to use the concept of NOT. So in AND you got 0, 0, 0, 1. So you have to just take the complement of that thing or NOT operation of that thing. So it will be 1, 1, 1, 0. Okay. So this is nothing but 1, 1, 1, 0. So how to understand or how to simplify this thing? The thing is, if both the inputs are 1, if both the inputs are 1, then only the output is 0. In case of NAND gate, if both the inputs are 1, then output is 0. And if one of the input is 0, if at least one of the input is 0, output will be 1. If one of the input is 0, one of the input is 0, then output is 1. Okay, this is the logic followed. Then, like a NOR operation. In order to understand NOR operation, you have to understand OR operation, and that I already explained. So this is the NOR gate. You have OR gate, you need to give one bubble in front of that one. It will be a NOR gate. Now, what is the expression of NOR gate? You write down the expression of OR and make a NOT operation. Okay, so this is NOR operation. So how the truth table is given as A and B are the input, Y is the output, 0, 0, 0, 1, 1, 0. So this is just similar to that one. So whatever OR operation you have done, you have to make the complement of that thing. So you have got 0, 1, 1, 1, 1. Now the result will be 1, 0, 0, 0. So the complement of the output, whatever you got in case of OR, that you need to do. So that is 1, 0, 0. So what does it mean? If one of the input is 1, then definitely you are going to get the output of 0. If both the inputs are 0, then only you will get the output of 1. This is the logic followed in case of NOR operation. Fine. Then next is XOR operation. What is XOR operation? So this, all of you know, this is the XOR gate. Two inputs A and B, and the expression is given as Y equal to A bar B plus A B bar. And this is given as this form A XOR B. Okay. Now the truth table of XOR gate. So A and B are the inputs and Y is the output. Make 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. So in that case, if one of the input means if the inputs are complementary, then only the output will be 1. So complementary means one of the input is 1, other input is 0. One of the input is 0, other input is 1. Okay, so the inputs are complementary to each other. Then only the output will be 1, and for the remaining case, the output will be 0. Remaining case means if both the inputs are same. So in this case, the inputs are same, means these are 0, 0. In this case, inputs are same, these are 1, 1. And in the cases, your output will be 0. If the inputs are different, then only the output will be 1 in case of XOR. Okay. Now the next operation, XNOR. XNOR operation. So this A and B are the inputs. And you know this is the XNOR gate, XOR gate. In front of that one, you need to give one bubble. It will make XNOR. And what is the expression of XNOR? A bar B bar plus AB, and it is given in this form also. This is the symbol of XNOR. Okay. Now, how the truth table is given as, if you know the truth table of XOR, you can easily find out the truth table of XOR. You need to do the complement operation of the XOR. So 0, 0, 0, 1, 1, 0, 1, 1. So whatever output you got for X1, you find out the complement of that one. This will be X1. So how to understand this table? If both the inputs are same, then only you have the output of 1. If the inputs are different, if the inputs are complemented, or if the inputs are different, then only you are getting the output of 0. And if the inputs are same, then only you are getting the output of 1. So XNOR operation. So these are the Boolean logic operations generally what we do. These are the basic operations. Okay. So other than that, some laws are there that I will discuss in the next lecture. Thank you.